Okay, so a quick review last time whatever we have done. Okay, last time first thing we saw was what are the changes in the interface, and the additional things in interface in Java. Okay, those were the default methods and the static method. Those are the two additions to the interface. Okay, and then definition of a functional interface, a interface with single abstract method, right? Fine. We understand a lambda expression as representing a function. Fine, because a function basically is what? Has some inputs. Okay, so yeah, lambda expression is nothing but giving a list of parameters maybe. Okay, a lambda operator, and then we have an implementation of a function. Okay, fine. So this we understand is nothing but we are writing a function. We can create a function object. Fine. But then every function object, okay, the main the identity of the function is basically going to be identified based on the signature, right? What is the signature? Defined by input parameters and whatever is your return statement here, the type of the return. Okay, that defines the signature of a function. Method signature we call that, right? So, so a function is identified by this, right? Another thing we see is, okay, every function has a type. Okay, of course that type is also nothing but dependent on its the type is according to the method signature. Okay, fine. And a function type corresponds to a functional interface. A function type corresponds to the abstract method of a functional interface. Okay, fine. So we can relate or see. Okay, what we'll do today is we'll look at our the code which I had uploaded in the class. Okay, fine. We'll discuss that code. And have some exercise from there for creating a functional interface. Okay, let's see whether, or I think if it's ready, I'm not sure whether that code for functional interface already exists. Then we'll just discuss that part. Okay. Okay, but fine. Let me discuss the code. Fine, whatever source code I have uploaded, let me discuss that. Let's have a review of what is that source code about, right? Okay, so it's the basic thing there is that we have a class. The basic entities which we have defined there are, one of them is a class called account, and this has got two subclasses. There are two subclasses of account. One is the current account, and other is a savings account. Okay. When this is how it has been done, and we have account class as abstract. Okay, with the two subclasses being non-abstract. Okay, and yeah, as far as account is concerned, an object of account, if you look at an object of account, yeah, what all it manages, right? An object of account will manage, so there will be one account number which we have taken as long. Okay, there has to be a name which will be of type string, so this will have reference to a string object which will be a name. Okay, fine. There is a balance which is being managed here, okay, which is again of type long. Okay, and then we have one more field. Okay, every account is managing a list of transactions which have happened on that account. So account class has methods for deposit and withdraw. Okay, so whenever someone does a deposit or a withdraw, fine, it would result in some, we say this is a transaction which is happening on the account, and therefore what we have here is we are managing some array list. Okay, so there is an array list. Okay, so the array list containing references to object of a transaction. So there is another class which we have under the account class as an inner class. So account class has an inner class called transaction. Okay, it is so the definition of transaction is inside the account class itself. Okay, this is managing details of the transaction which have happened. So it will be since this is a transaction object. Okay, every transaction is created. It's an inner class. Therefore, it is created with respect to the account object. See, it always it knows its account object. Okay. But what we are doing here is in the account also, the account keeps track of all the transactions which it will create, which have been created for this account. Okay. So here what are the fields it has got? It has got a date time field, okay, to manage what is the date and time of transaction. So it's some date time field. Then it would have a field for whether it's a the type of transaction. Okay, the type of transaction. So it is a enum basically. It's a deposit or a withdrawal. So it's a debit or a credit transaction. So what is the type of transaction? Okay, fine. There will be a narration for the transaction. A string would be there, which is a narration. Then there is a type, and then we have the amount of the transaction, the amount of transaction which has happened. Okay, this is the kind of thing which we have structurally. Okay, and then another thing which was added to the structure was another class which was defined. So basically, if I look at account has its own fields, but one data structure also it is managing. It is managing a list of its transactions. Fine, that is something which we wanted. So account managing a list of transactions. Okay. Okay, and then later we have another class. Okay, there's another class called bank. So that's a separate class called bank. Okay, and an object of bank. If I look at an object of bank, fine, a bank object would have a name, a bank's name. Okay, a bank would have a code, right? So a bank has a code, but using that code, we are using it in a different manner. What we are doing is we are using the bank code to generate the account numbers, right? So each bank has a different code, and based on the code, the last 4 digits, mean whatever is the code, add 4 digits to that and create a account number for the accounts which will be managed by this bank. Okay. So every bank manages every bank will be managing accounts. That's the whole idea, right? So it will what it is managing is what is the last account number it has allocated. Okay, so there is one field for last account number. Fine. One is a bank name and last account number, and then we have a data structure called map. Fine. What is the map having? A map is having a mapping of account number with the corresponding account object. We understand account object is of this type. Right. So a number of so the idea here is we are having a mapping of account number with the account objects, because we would like to do operations on a bank using the account number. So given account number, we would like to fetch the account object easily. That's why we are managing them in a map. Okay, fine. Let's look at that code now. Fine. I have just given the idea of what is the kind of structure which we are having. So the idea here is bank manages accounts and accounts manage transactions. So we have 2 levels, right? Bank at a higher level, which has to manage its account objects, which is being done in a map structure. Okay, and each account in turn manages its own list of transactions. So that's there in a list structure. Fine. Okay. Let's quickly look at the code for this. Okay, and then we'll see where we will use the functional interface and other things. We put it in a package bank, and here is the account.java. Okay, there's a lot of to do things, right? So I've left things for as exercises here. Okay, so yeah, what account has done in the account class, we have a last account number as a static variable. That was just to test account class when there is no bank or anything involved, so that automatic account number can be generated right with the account class itself. Okay, otherwise we don't need that last account number in the account class. Okay, fine. For our final exercise, yes, when we have the final version, the bank is managing the accounts. Fine, and we won't need that. Okay, fine. Account number, name, balance, and then we have a list of transaction, where transaction is the inner class. You can see the transaction as an inner class. Okay. What is being done here is we are using long to maintain date in milliseconds. Okay. So whenever the transaction object is created, at that time whatever is the system's current time in milliseconds, that's being captured, fine, as and managed as a date value. Okay. There is a narration which you can have for the transaction. The type of transaction is a enum. We'll see that here. The enum definition also happens somewhere below this. Okay, we have the amount of the transaction, and then we have a normal constructor which will just check the. Okay, in the constructor we are just doing a check with the amount. Amount should not be negative for the transaction. Right? So amount cannot be negative for a transaction. So accordingly, we have defined our own exception class called negative amount exception, and we'll give a message there. Okay, fine. So we'll throw an exception in case someone gives a negative value. Okay. So the usual things in constructor assignment of the initialization of the variables, but now, so this is narration, transaction type, and amount. They have been assigned. But now look at the next statement. Statement says account.this.balance plus equal to this dot get net amount. Yeah. What is the idea of this? Account.this.balance. Why do we say account.this? Inside the inner class, right, we will have two implicit objects, right? We know this is an implicit object which is available to any class. For any class, whenever you write any class definition, right, this means the object of that class, the current object of that class, right? But now if it is an inner class, there are two objects available, right? The object of the inner class, as well as for every object of the object of inner class is always created for some object of outer class. So that outer class object will be available by using outer class name dot this. Here for transaction, account is the outer class, and therefore we are saying account dot this to mean the account for which this transaction is being created. Okay, so the account for which the transaction is created, in that the balance is updated here only. So we will not update balance inside the account class, but if you only when you create a transaction, the balance is going to be updated. Okay, so that's the statement. And same way, account.this.passbook. Now what is passbook? Passbook is that list for managing all the transaction objects. So in the corresponding account object where all the transactions are being managed, okay, we are adding this current object of transaction which has just been created. Okay, so that's what is being done in the constructor. Fine. So yeah. Okay. Fine. And then the usual methods called get date, get narration, get transaction type. Okay, transaction type is a enum. We have the get amount method, but then we have this get net amount method. Amount we understand is always going to be positive, but then we have the get net amount, okay, which says, now if you look at the get net amount, what does it say? Okay, transaction type, which is an enum. Okay, so get the sign of that transaction type. So it would be +1 or -1. What we have done is, the two transaction types are there. There is a debit and a credit. So if it is a debit, it will be -1. If it is a credit, the sign is going to be +1. Okay. So we have used it here like this. So whatever is the transaction type for the current object, okay, get the sign, okay, and multiply it by the amount. That is what is to be. That is the net amount. So the net amount is going to be positive or negative depending on the type of the transaction. Okay, and then of course there is a toString override. That's fine. It's just the string representation, how we want to convert to a string. Okay, and here comes the transaction type. Credit is sign is 1, debit sign is -1. Fine. Initialize, there is a constructor and there is a get method for the get sign. Fine. Simple. Okay, a simple enum class, right? So it keeps the sign. Every transaction type has a sign which will be +1 or -1. So there are two transaction types here. Okay. Fine. And then we have the constructor for account. So if someone creates an account object for the first time, yeah, you will have account number, name and balance. Okay. So the normal thing is the assignment, but then we are not assigning anything to the balance. Instead, we are calling the constructor of transaction. Fine. Where the narration says that this is the opening balance. Okay. Type is credit, and whatever is the amount he is calling in the constructor. So when you create an object of account, you give the opening balance. Okay. There is a second constructor which is using the static variable. So automatic account number generation if you want with the account only. So that's why the second constructor is there. May not be necessary. Okay. And we just this was there so that we could test and create account objects without even a bank being involved. Fine. For the testing purpose it was there. Fine. The usual getter methods, get account number, get name, get balance. Okay. Deposit, when someone says deposit, no, we don't update the balance here. You can see the balance updation happens only in one place, that is when the transaction object is created. Only from the construct of transaction the balance has been updated, no other place. Okay. So if balance has to be updated, okay, call the construct of transaction. When you call the construct of transaction, it not only updates the balance, also puts an entry in the list. Okay. Fine. So we are ensuring that if amount has to change for any reason, there must be a transaction. Okay. That is what we have ensured in this kind of coding. Okay. And no one can create no one can update a balance without having a transaction for it. Okay. Fine. So just like deposit says new transaction, for withdrawal we are just checking whether a balance is available or not. If balance is not available, fine, we will just return false. So withdraw would return true or false. Okay. And then a toString method, that's fine, and a display method to display whatever is the. So this is a simple account class. Okay. What we have done is in the subclass called current account. Okay. And just quickly look at it. Okay, in the current account we have done in current account we initially we have kept a static variable for minimum balance. Okay, so there is some minimum balance which all accounts will have to manage, and what we have also done here is we have said, okay, we have a penalty, we have a fixed penalty amount, right? And so current account says, okay, if you want to create a current account object, fine, the same constructors as whatever are the constructor for account, same constructor available for current account. It's just using super. Okay, so that's one constructor, that's the other constructor. So two constructors, they are there. Okay, we have added a field for penalty. Every current account has some penalty amount. By default it would be 100, okay, but could be changed. So there is a set penalty method. Okay, and how it is used? It is used from the withdraw method. Fine. So in the withdraw method, you do the usual withdrawal the way it is done for any other account. Okay, so it's doing a super dot withdraw, but immediately after that, if there's no balance, okay, there's no point in going further. But if there is balance, the balance has been updated. Okay, but if the balance is updated, we also do another check. Now after the updation of balance, is the balance falling below the minimum balance? If it has gone below the minimum balance, then we'll also apply a penalty. So penalty, there's a transaction for the penalty, which is a debit transaction now. Okay, fine. So there's a transaction for the penalty which is done, which is a debit transaction. Okay, this is what is done here. Fine, and then anyway, because withdrawal has taken place with or without penalty, we are returning a true here. So this is what current account has done. Okay, now look at the to do here. What does the to do say? Right? Use a function for penalty instead of a value. Right? We have a fixed value of 100, right, which is saying, oh, penalty is a long value, right, just some value. But instead of value, can I have a function? Can I have penalty as a function of whatever is the minimum balance and what is the current balance, what is the balance he is, so how much is the shortfall? Depending on the shortfall, we may have a different penalty amount. Maybe it is some percentage of the shortfall. Fine, he is falling short for the minimum balance by a certain amount. So that much can be the, so our penalty could be dependent on that, maybe some percentage of the shortfall. Okay, so more the shortfall, okay, he'll have more penalty. Fine. So so that is the first exercise. So now it says, it's talking about a function now. So what is it that we should be doing? We should be defining a, we should be defining for how do we represent, how do we write our own function type? We have to create a function type. That means, how do we create a function type in Java? By having a functional interface. So we must create our own functional interface for penalty. Okay, fine. So let's see how it can be done. Is the code for penalty given? No. No, it's not there. Okay, so let's do that exercise. This one. Fine. Okay, so let's do that. So let's define our own function type. Okay, how do we go about it, right? Let's see. So we'll have a package bank, okay, and we'll have a public class called, not class, it will be have to be a interface. Now we know there are annotations, right? So we have an annotation which we can use, it's optional, okay. Whenever we define a functional interface, we have a annotation which we can apply here. We can say @ functional interface, and then define a public interface penalty. Yeah, what goes in this? One abstract method. So what is our abstract method? We can have a public abstract method. Anyway, public and abstract, even if I don't mention. So default is public and abstract. This method has to return the penalty amount. So let's call it returning long. Okay. Method name compute. Okay, it computes. It has to compute the penalty. Okay, what are the inputs to this? One will be of type long. It will be the, let's say, the minimum balance, and another long for whatever is the current balance available. Yeah. So this can be a abstract method. Fine. So our function takes two inputs of type long and returns a computed penalty value. Okay. Fine. We understand we can add default methods, we can add static methods here. Okay. Fine. Maybe we might like to even add some static constants. Okay, so let me just create a static constant for you, fine, to get an idea of what kind of things we do with a functional interface. So fine, so we'll say, okay, let's have a public and a static variable. Because it's a variable, it's going to be of type public and static, public, static and final. The type of the variable I'm saying is penalty. I have a function object here, okay, which because it is static and final, I am going to use capital letters, 0 penalty. Let's have one function object of type penalty, okay, which we call as 0 penalty, and let's create this equals. Okay, I must have the assignment here because it's a static and final. What do I assign here? A function. And what is that function going to be? Okay. And what do I return? 0. So anywhere you want to set penalty should always be 0. You can set this. Fine. You have this function object. Okay. Fine. When is this clear? This is a Lambda expression we are using. We have a function.
So here,
yeah,
here the penalty object, what has been returned, its interface itself.
This is interface, right?
Yeah.
Okay. This is interface.
And on line 7.
Okay. On line 7, I have declared a variable of that same type.
Yeah.
Okay, like okay, this is a variable, right? It's a variable, right? It's not a function. Okay, let me put public static.
Yeah.
Fine.
Okay.
Fine. The type of the variable is the same, right? It is same as the penalty, and I have given a variable name as 0 penalty. And how do we write a object? How do we create an object of a functional interface type? We can create it like this, or someone would have done an anonymous inner class also, but now since we have Lambda expressions, we forget the anonymous inner class. Right? right? But
Okay.
this lambda expression is okay. What does lambda expression have? Input parameters. So this is nothing but object, okay? This part is nothing but a object. What is the type for this object? Penalty.
Penalty.
The type for the object is penalty. Why? Because it matches this. It matches the compute method signature. The compute method says I will take two parameters, long and long. Okay, I am taking two longs. Okay, these are longs. Okay, it must return a long value. Okay, I am returning 0, which is the long value for this one. Right? Okay, everyone gets this?
So, sir, can we directly assign 0 instead of the lambda expression?
Assigning 0? No. 0, what is the type for 0? That would be long. But what are we having on this side? Type is
Penalty.
It must be a lambda expression. It must be of type penalty. It's not that it must be a lambda expression only. Someone goes for anonymous inner class and puts it there. That's also okay. Fine, someone could have done a anonymous inner class for the penalty. Penalty is an interface. You could have written an anonymous inner class to implement this method. Okay.
Okay, so for the type penalty, we are providing the implementation of the abstract method, right?
Yes, in a lambda in the form of a lambda expression. The lambda expression is for creating the object of a functional interface type.
Okay.
Okay. Fine, comfortable with this one because we are proceeding further. Fine.
Yes, sir.
Now let me give another example. Okay. So we'll have a public and yeah, let's have a public static method now. Okay, it's going to be a method, but the method is going to return a penalty object for me. Okay, the method will return penalty object. The name of the method can be, oh, I want a penalty based on the percentage. Okay, percentage of the shortfall. Fine, I am saying percent, but that's percentage of the, or yeah, or instead of percentage of a shortfall, I can, okay, let me go for a easier one. Let's say, I say, oh, I must have a fixed penalty. The penalty object will always give a fixed penalty amount. Okay, and what will that amount be? Okay, let that be the, so let there be some penalty amount. Okay, the penalty amount which you want, right? So I have to write this method now. It's a static method which we are writing. Right? It's a fixed is a static method. How will invoke fixed? By saying penalty dot fixed, and when we call fixed, we have to give that fixed amount. Okay, that fixed penalty amount which we want for the function to return. Okay, what should this be returning? After return, what is the type required? This method must return of which type?
Penalty.
Penalty type. That means I can write a lambda here. Right? I am returning a object. I am returning a object which is of type penalty. I am returning it by I am creating it with the help of a lambda expression. Okay, and yeah, what is it that I will do now? Okay, given balance and minimum balance, what I must always ensure that a penalty is not wrongly to be charged, right? So I have been given minimum balance and balance both. So I must check, okay, only when if balance is less than the minimum balance. Okay, question mark. Ternary, I am using ternary operator. So if balance is less than minimum balance, then I will return the otherwise I will return a 0. This is a lambda expression. Okay. Want to start using it? I want to use this method. And let's see the usage of this method. Or is this okay now? Is this everyone is comfortable? A return statement with a lambda. So where is lambda? In the assignment, right hand side of an assignment, right? Where is lambda? With the return statement. Yeah. Or I'll add one more method first. Penalty. We have, oops. Or okay, I'll give a different example. So for that, what I might use is, I might use similar to the public static. Let me have a variable first, and then I'll go for the method. Okay, I'll again add another variable of type penalty. Now that was 0 penalty, but let me say I have a default penalty. When the variable name is default penalty, and I am going to use a lambda here. Okay, and look at the way we might compute. Okay, so this lambda has a body now. Okay, it's a block of statements, not an expression straight away, which is to be returned. Okay, fine. So let's see how we may compute a. So first thing, find the difference. Long shortfall equals. What is the shortfall? Minimum balance minus balance. Okay, just put that statement. Shortfall is minimum balance minus balance. That's a shortfall. Okay. Now you might have some ifs like this. If shortfall less than or even if it is equal to 0, when shortfall is less than or equal to 0, okay, I am not using block here, though that's what is recommended. Return 0. Fine. Okay, there is no shortfall basically, less than equal to 0. And then if shortfall is less than or equal to 1000. Okay, in which case let me return 100 if shortfall less than equal to fine. So we are doing blocks, right? So if it's in this block, I return this much amount. Okay, the penalty is computed with blocks. Maybe I'll give a bigger block, 5000. So we have 500 after this, or else if you return 700. Okay, maybe. So okay, you can see this, and there will be a semicolon here. Yeah.
Yeah, on line 11, when we when we pass the minimum balance and balance, right? What will be the type of those two parameters? It will be, so on line number 12, it will get casted to long.
It will be, yes. See, you have the option of mentioning. This is also okay. You have the option. You can always mention. Okay, but this can be inferred. This can be inferred because on the left hand side, what is the type? Penalty. Okay. Now it will go into penalty and we'll see, oh, what is the abstract method in penalty? Oh, this is the compute method is the abstract method is penalty, and this is taking long, and therefore those two parameters are long.
So there must be only one abstract method, right? It cannot be more than one.
Not more than one abstract method. That's what is a functional interface.
Okay.
A functional interface by definition is the one which has only one abstract method, single abstract method. Okay. Fine. Are these things, you feeling comfortable with this kind of lambda expressions now?
Yes.
Okay. Fine. Same way. 1 second. Let me just check it. Okay, fine. I'll give it as an exercise. Okay. Okay, I'll put the method signature. Public static method returns penalty. Our aim here is to have methods by which I can create penalty objects easily. Okay, and this static method name, let's call it as %. Okay, and it would take as parameter, how do you want to specify percentage? As a double, maybe 0.15 means 15% or something like that, 0.1 means 10%. Okay, I want to specify as a int value, whole number. Let's have double. Okay, percentage. Okay, it should return penalty. Let me call it penalty function. Okay, fine. So I'm leaving that, right? Okay, so we save this as penalty.java. Okay, fine. Now let's see how this may get used. Yeah, how is it going to be used now? We don't have penalty as a long type, but rather we'll have as a penalty type. Penalty is a type, it is now a function. You want what? Equals fine. We have that object, we can straight away use it here. Okay. Or see, instead of penalty dot default penalty, someone could have even written it as penalty dot, the way it was happening earlier, it had 300 100 was the amount, right? Yeah. That could also have been done. Instead of saying penalty dot default, someone could have called the static method called fixed, penalty dot fixed 100. See, when we do this, penalty dot default underscore penalty, there is no computation of penalty happening in this line at all. It has just created, fine. When we have written this method for the penalty, coming to the penalty here, okay, when we write all these methods in the entire code, okay, there is no computation actually happening. The compute method has never been invoked in this. It is just creating the penalty object for us. It is creating function object, not executing that function. It is not executing that function, it is creating our function object, but not executing the function object. We want the function object's execution. Oh, where should it be executed? When do we have to compute the penalty? Oh, we may have to change here also, get and set method, sorry. Set penalty will not take long, but it would take penalty, and get penalty returns penalty object. Okay. Now, coming to the computation of penalty, this dot get penalty dot compute. What do we pass? What is it to be passed? Minimum balance and this dot get balance. Clear? It is not a fixed value. We are now using a function. The compute function on that penalty object is used for knowing the penalty amount. It is from here that that function which we have defined is getting invoked. Before this, no invocation of the function happens. It just builds the function object and keeps it in those variables. Fine. A function object is being created and made available through variables like zero penalty, default penalty, fine. Or if when someone will invoke those methods like fixed, okay, right. If someone says penalty dot fixed, it's creating the object, it's creating the penalty object, not executing the function. It's creating the function object, not executing it. And then it will be kept in the whatever is returned by that fixed method. Okay. Fine, that will be available through this variable. This is penalty variable, right? This is the penalty instance variable. So this dot penalty, fine, dot compute. Compute is a method in the penalty interface. Compute is the actual method which is going to invoke the method represented by this function type penalty. Penalty is a function type. And is this clear?
So we don't need to provide the implementation for the compute method here.
It's there in the like whatever object is there, that object, how was the object of default penalty created? Penalty dot default penalty we have written, right? How was the object of default penalty created? Oh, it's here, default underscore penalty. So we have written the implementation, but when we are writing the implementation, it's just creating the object of a function. It is not executing the function. Okay?
Okay.
Right? This whole thing is not executing the entire function. This body is never executed here. When the body is executed when someone calls compute on default penalty object. Fine. This becomes clear now?
So this is is moreover implementation interface. Then what is difference between this function interface and DAO class? This is moreover data access, right? We are computing something inside interface.
In this case, yes, you have used for computation. These are only pure functions only. These are just functions. This type represents a function. Okay. So in this functional interface, it is of a type which takes two long inputs and returns one long. Okay. Fine. There are lot many functional interfaces in our API. Prior to Java 8 also, right? Action listener was an example, okay, and similarly there are others. Fine. For example, in the Java.io package, we have file filter, file name filter. They return a boolean. They take input as file object. Fine. Or file and a file name, directory and a file name, right? But they have to return a boolean. Now anything which returns a boolean is normally to be classified as a predicate. See, what has been done is, we already had interfaces, okay, but then if we have some standard things, okay, then we could develop on top of it. Fine, we could develop on top of it. Okay, I'll now show an example. I'll now show another functional interface. This is just to show how do we create our own functional interface and how do we use it. Right? That is the purpose here. Okay. Fine. Is this clear? Fine. Defining our own functional interface. What kind of things may be there in the functional interface other than an abstract method? Why someone goes for static methods? Okay. And you may even have default methods. We'll see examples of default methods in some of the API interfaces. Okay. Fine.
Okay.
Yeah, we'll see examples. Yeah.
Sir,
Yeah.
so functional interface is like saving lots of implementation code, right?
Saving lot of typing, that is one thing, but it allows you to think about functions as a type. Functional interface is allowing you to think about function as a type. A lambda can be looked at as a function, but no one could have imagined interface being looked at as just a function. Right? So interface is giving me a type. Actual implementation is always written in a block or something like that. So yes, you have a few shortcuts, not giving name at all. Fine. Not writing return statement if there is only single expression. Fine. So there are some shortcuts of it, but yes, it is a function implementation. Lambda expressions are function implementation. Okay. And see, our interfaces which had one abstract method, what we were doing normally was writing anonymous inner classes by overriding that abstract method only. So the whole idea was, oh, this interface is this functionality. This interface has a particular functionality. There are different implementations of that functionality. Okay. And those different implementations earlier may have, someone might think, oh, I write different anonymous inner classes for that same interface type. Now, instead of writing anonymous inner classes, you are writing Lambda expression, right? Fine. See, this code looks much easier as far as writing function is concerned. Only thing is, we have to get used to that Lambda expression kind of a thing. Okay. Again, we will see method references also again. Fine. Once we get used to it, fine, we will then come to method references. Let me take a few examples where this kind of thing is going to be useful.
Sir, just a small question.
Yeah.
So, in the previous class, that is test function interfaces, where we have called this dot panel t dot compute.
It's here. It's in the current account.
Yes.
Yeah.
Yes. So, in the current account, this dot penalty dot compute will indirectly call penalty dot default penalty, right?
Penalty dot default penalty is same as because that's how we have initialized. How have we initialized? Penalty dot default value. That's all fine.
So,
Yeah.
correct, sir. So, if I want to call zero penalty, I have to create another variable here of penalty type and
Okay.
call it using that, right?
Okay. What we have provided, if you look at it carefully, we have provided with method called set penalty. Okay. Let's say we go to the test account class. Okay. I am going to the test account class now. Okay. Now, in test account, we have created a number of account objects. Some of those are current account objects. Okay. Here is where we have created. So, there is a class called test account in the test package, because that is a place. Now, it is here that someone might call the method on a current account ca.setPenalty and passes a different penalty object. He could use set penalty, penalty.zeroPenalty on this current account. I have said ca.display, right? Fine. But I could also have been calling, now what I can also be doing is I could be calling, okay, let me do it here, ca.set penalty and you could have done like this, or ca.set fine, and given some amount, maybe 300, always penalty will be 300 for this guy, or someone could have said and maybe 0.15, 15% I want. I am assuming percent has been implemented, or someone could also have been doing and writes a lambda and writes a whole thing. Okay, could be writing the whole thing with a proper return and everything, right? Okay, see the options he is having now. For any current account object, set a penalty function which you like. You can have your own customized function, right? We had written penalty, a default penalty the way we have written. Oh, you write your own thing here, right?
So on line 36, we are overriding our implementation.
Yeah, we are giving the
for the
implementation. What we are doing is we are setting up a function. We are not fine. We are just setting up the function for penalty for this current account object. How penalty will be computed whenever it has to be computed? From where it is called? Oh, it is called from withdraw method only. The compute is only called from withdraw method. But how is the compute to be done? How is the compute? How is the penalty be computed? To be computed, okay. You have all these options now. See, if I had not written fixed, right? If I had not written fixed 300, it would have been a lambda expression. It could have been a lambda expression to do the same thing here. Fine. What I am doing is in the penalty interface, it's not only acting as giving just abstract. Its job is not only to give one abstract method. Okay, my job is done. I'll give you more facilities to create objects of this type. Some very commonly used function types, you can create them easily. Fine. Oh, commonly used functions for penalty maybe somewhere you might have a privileged customer, you want to have 0 penalty for them. Okay, fine. Have such an object. You don't have to write. Fine. Or most of the time you have some fixed amounts for them. Okay. Or it is based on percentage of shortfall. Okay. You can create those objects easily, or have your own customized thing. But for customizing, it's the programmer's customization. The one who is using the set penalty method, he says, I want to use such a penalty implementation. Compute implementation is to be like this. Getting the point?
Yes.
Yes, sir.
And so you should feel comfortable with this. Okay, lambda syntax should not create any problem for you now. And because initially that lambda syntax is slightly intimidating. So it may look, oh, what is this? How come suddenly something like this has come into Java? But the first look for lambda expression was like that for me. Oh, what is this? What has come here? Okay. Fine. So let's proceed and look at some standard functional interfaces, a whole library which has been provided to us. Okay, and the purpose. So because I would like to show you the purpose first, okay, and then I'll go into what are all those standard functional interfaces. Okay, so I'll first show you with one on. I'll just give one example. Okay, one example of a functional interface. We'll use it. Okay, we'll see where it is used, and then we'll proceed with what are the whole list of what are all the standard functional interfaces. Okay. Okay. So the function interfaces, the standard function interfaces. Among the standard function interfaces, okay, last time I had shown this, that yes, you view a function, a functional interface type as that abstract method has to be viewed. Now when I view a method, okay, I will be viewing it as, okay, I have some inputs and I have some outputs. Okay, I will have a method name, input type, output type, method name. Input parameters, output can be 1 or 0. Okay, there can be multiple outputs. Okay, fine. So I'll just represent it with a box. Now one of such box or one such, so now one place where we have a standard set of function interfaces which have been used throughout the API, and how and why they have been used, I'll have to come after I take one function interface from this. Okay, so I have a function interface. We have this package called java.util.function. Okay, that's a package. Okay. In this package, one very commonly used functional interface. This package has how many functional interfaces? 43 of them. And don't worry, you should be able to remember each and every one of them. Okay, there is a way how we can remember all of them, but let us first finish off with understanding one of them and the usage of it. Okay. So, one such function interface is called consumer of T. One such function interface is, it is a generic interface, consumer of T. It has an abstract method. So, it has one abstract method. The method name is accept. Oh, method return type. I must show the return type first. Return type is void because it is a consumer. Consumers mean they do not return, they will just consume. So, return type void. Consumer means return type void. So, anywhere we find return type void, oh, it is that consumer category. Okay. Fine. The name of the method here is accept E. This is E. Okay. And parameter is T. Right. So, it takes one input which is of type T and does not return a value, it just processes that object, fine, consuming the object. Okay, do some processing with that object. Okay, fine. So, this is one interface, function interface. So, if I have to write a lambda expression, it would look like this, right. We have understood one thing, that if you have only one parameter, I need not even have the brackets for it. Okay. And then I might have something, but it does not return, it would not have a return statement. It may just say return, yeah, you do not need a return statement in this. Okay. It is of this form, right. A lambda expression, if it has to be written, would be written in this manner. Now, let us say you got a data structure, it is a collection. You got a collection of E. Yeah, they have used the type name as E in case of collection interface. So, I have used that same type name here. Fine. We know the methods of collection which were there up to Java 7. Okay. Now, what happened in Java 8? We have default methods also, and therefore, a few default methods got added to this. And one of the default methods which is available on objects of collection, collection actually inherits from, it extends the interface called iterable. Okay. And from iterable, what it is inheriting, that one of the methods which is a default method in the collection interface, okay, a default method in the collection interface is returning. Okay, here the return type is void, name of the method is for each, and the parameter to this method is consumer of, okay, let me not use the wildcard, I will just simply say E, otherwise it is question mark super E. Okay. To make it, keep it simple, okay, I will just say, okay, so for each consumer of E. This is the action to be taken. Okay. Now, let us assume we have a collection of account objects and we would like, let us say we have a, there is an interest which has been computed for all of them. So, there is a procedure of computing interest and depositing into the depositing the interest into the crediting the interest into the account. So, this has to be done for all the accounts, maybe all the savings account, maybe Okay. If it has to be done for all the savings account, how would it be done? Yeah, how will you go about it? Okay, let me put something like this. What you have maybe is a collection of account CA equals something has been assigned. So, do not worry about how it has been created. Maybe it is a array list or anything, but still it is a collection. Okay. So, CA is the collection. Now, if you have to update every collection, every account object in this collection, fine. Okay. How will you do it? The most common way people would start, okay, would be saying, oh, let me now have a for each loop, right? For each account AC in CA, and then what do we do in this? Write the code for processing. Some processing is to be done, okay, right? So, what are we doing in this? We are writing a loop where the loop is extracting the elements from the collection one by one. Extract the element from the collection, do a processing, extract the next element from the collection, do the processing, extract the next element from the collection, do the same processing. Why don't I give that processing to the collection, say do it on all? Okay. Why don't I do it this way? Yeah. Yeah. So, the idea here is you can say CA dot for each. Do not extract the things from the collection. Do not extract the elements from the collection. Instead, give the action to be taken on all elements to the collection. What is the action to be taken? Given an account AC, so sorry, it would be this way, right? Fine. See, what is the basic difference? You can see the difference in approach. You take out element, do processing, take out element, do processing, take out element, do processing. It is the same processing for each of them. Okay. Oh, what is that processing? You give it to the collection, he will know how to do it. Fine, collection knows how to do it on all of them. The collection will take care of doing it on all of them. Another thing, does it matter in which order it is being processed? See, updation of balance has to be done, updation of interest amount has to be done in all of them, right? Is the order important to me here? If order is not important to me, okay, and I am giving it to the data structure, see, I am giving it to the data structure, I am giving the processing to the data structure, you do the loop, I do not have to write the loop, you have to update this, you have to do this processing for every element. You are concerned with what is the processing which is to be done rather than writing the whole loop, extracting. There are extra steps involved. You have your variables like AC coming into picture. You don't need such a thing. Okay. The point is, since the order is also not important to me in which all these are getting processed, and my machine may have multiple cores which are lying idle. When I say ca.forEach, maybe this for each, which is written by experts, may have been coded in a manner where it breaks all those account objects into smaller categories and tries to process parallelly. Parallel processing by splitting the job can be done. If you were asked to do to write a code, you won't go for parallel processing, you won't think about it. This is purely sequential. When you are writing like this is purely sequential, whereas this is not. It's hiding completely from you how it is done. But yes, it will apply that action on all of them. Okay. The idea here, what I am saying, the idea here is, since I have a standard functional interface called consumer, it is a standard functional interface, okay, and therefore, oops, okay. Since it is a standard functional interface, right, and therefore, in the collection interface they have used it. They have been able to use it not only in the collection interface, there will be so many places where a similar kind of thing. What is important to me? A kind of a function object, okay, where which is a consumer category, where it takes input but does not return output. It will take anything, any type T. You decide the type and it will take type T and do the processing. So, consumer of T can be used in different parts of the API. There can be so many utilities built for the consumer. It is a standard function interface. It is part of the API. Okay. Fine. Okay. So, like this has been used in the API. Okay. The other 43 of them, they are also candidates. Fine. So, when you want to have something, when you want to use the various APIs which have been created around the collection and around the new things, the new thing here is the stream API. Around that new thing called stream API, okay, fine. When anything is to be used, it is going to be fine. It is going to refer to the java.util.function package. Okay. Let us see the core categories of functional interfaces there. And can we move to the, is this clear? That we have functional interfaces which are there as part of java.util.function package, and they have been used in the API. I have just shown one example of usage of consumer. One place where it is used is collection. It is not only collection where it is used, there is a number of places where a consumer is used. So, there are utilities built for consumers, there are utilities which are built for predicate, there are utilities built for supplier, there are utilities built for function. Yeah, we will see what that all those different types of things are. Okay, fine. So, shall we proceed and look at the function interfaces, the various categories, what they are?
Yes, sir.
Okay. So, the categories of the function interfaces. Yeah, first type is consumer. Consumer means return type void. Okay. Those functions which do not return a value, they may take some inputs, but no value to be given out. They don't return, they do processing of the inputs. Okay. So, in this consumer category, see one thing, most of these function interfaces have been built for generic type, like we saw consumer of T, and they have been built for 3 primitive types. There would be things which are built for 3 primitive types, especially there are the 3 types are the int, the long and the double. Okay. So, we got here consumers like this. There are 8 consumers. Let us see which are those. So, we have the, for the primitives we have the int consumer, sorry, C-I-N-S-U-M-E-R, int consumer. So, method name is always accept. When it is consumer, for all these consumers, method name is accept. Okay. Fine, we had seen consumer method name was accept. Parameter for int consumer is the primitive type int. Same way we have the, like int consumer, we will have the long consumer, sorry, yeah, L capital, long consumer. It is the name of the function interface. Double consumer. Fine. Int consumer, long consumer, double consumer. Okay. Then we will have by consumer. Sorry, we have the consumer itself, right? Consumer of T. So, 4 are with single input, int, long, double or the generic input. Okay. And then we have the other 4 which is int by consumer of int by consumer. When it there is something called by consumer of T comma U. So, 2 generics, 2 inputs T and U, but no return value. So, there is a by consumer like this, and then we have obj int consumer of T. So, obj int consumer. So, first parameter generic, second parameter int. Accept method with first parameter generic, second parameter int. Just like int, we have long and double. So, that way we get 8 consumer. Okay. Okay, I think I will put it on text editor, so it is more legible. Okay. Okay. So, first category is the consumer. Okay, consumer category, there are 8 of them. Okay. One will be, okay, let me first the consumer first, consumer of T, okay, then int consumer, fine. The next will be by consumer of T comma U, sorry. Okay, and then we have the obj int consumer, okay. All these will have one type parameter T, because first is a generic in all these 3, first parameter generic, and Okay, and that's a consumer. Next category we can look at is the maybe want to look at supplier first. Suppliers will be 5, I think. Okay, there are 5 supplier. So supplier of type T. Okay, yeah, when it's a consumer, yeah, what's the method here? What's the method here in the consumer? Public void, return type void. Name of the method was accept. Parameter was T for the generic one, but according to those types, right, T or T and U, except with 2 parameters. The name of the method is accept in all the cases here. Okay, for all of them name of the method is accept, but for the second row, fine, there will be 2 parameters. Okay, in case of supplier, right, the method is public method. So I am giving for supplier of T, if it's a supplier of T, the public method here returns T, name of the method is get. Okay, so no input, fine, no input parameters, but returns T. Okay, fine. So first one, supplier of T. Here we got int supplier, long supplier, all cases method name is get, remember that. Okay, and we have one more, which is the, this is also boolean now. Okay, so there is one supplier for boolean. So there is only one place where boolean has been used, boolean primitive has been used as a parameter. Okay, that has been used as a parameter here, not parameter, return type here. Okay, so boolean supplier, no inputs but returns boolean. Clear? So these are the 5 suppliers. Okay, then we have predicate. Predicate are basically there for purpose of testing. Okay, booleans, they return boolean values. I think there are 8 predicates here, or 7 predicates probably. Yeah. Oh, 5. Okay, so there is a okay, the method here for predicate public method return type is going to be boolean. Predicate identified by this return type of boolean. Name of the method is test. Fine. Parameter is the generic type T, or whatever is, if it is a predicate for the int type, yes, the type would be int. Fine. The parameters are different types. Okay. So we have predicate of T. Okay. We have the int predicate, long predicate, double predicate, and we also have a by predicate of T comma U. Okay. See, what has been done here is they have tried to cover the common method signatures through all these function interfaces, most commonly used method signatures. So one method signature, one kind of a lambda expression, right? So it's like trying to cover all most commonly used function method signatures through this. Okay, so that's a category of predicate. Then comes a more general one, which is known as the function. Okay, there are a number of functions. I will not write the count here. Let's list them.
Each of these predicate in line 16 should have a this one, no, parameter T, right?
No. First one is T. Okay. For example, int predicate, the method would be public boolean test, parameter is int. So test a value of that type. Give that, and I will have to say true or false. Okay. it is supposed to be returning true or false. It's a test basically. Test this value. I have an input value, test and give me true or false for this. Okay, this account has a negative balance, true or false. That kind of thing, test can be there for first category. Int predicate, oh, it's a odd or even, odd or not, right? Or is it a prime number or not? Fine. So that kind of test. Okay, a test which returns true false. Okay, now a function is that kind of a thing which has input as well as an output type. It's not returning void, return type has to be something, and it has to, it's not having zero parameter, it has to have some inputs. Okay, predicate you can think as a special type of a function where the return type was always boolean. Okay, so in this category of function, okay, then basic method name is going to be, let me give the basic method. So first let me write the basic one, which is function of t comma r. Okay, if I look at this function of t comma r, the public method here would be returns r, method name is apply, and parameter is t. That's a value. Okay, fine. So a function of t to r, from t to r, it's like transformation. These functions do a job of transforming. They take one input and return something, do a transformation and give you something else. Okay. Okay, so let me now list all the functions here. First one, yes, we can put maybe function from t to r. Okay. Okay. Now, what I am giving here are one input, one output, that kind of things. Okay. In this line, I will just put one input, one output. What are all the possibilities? So, other possibilities are int function of t, int function of t, sorry, int function of r. When I say int function of r, what would be the method signature like? I will just give for int, it is going to be public method returns r, name of the method is apply, parameter is going to be int. Okay. So, similarly, we have the long function of r, double function of r. Okay, fine. And then similarly, now other way round. Other way round is what? If I look at int, long and double, right? Okay, or okay, within the fine, we have something which is where we have it within the primitive itself. So, we will have something like int to long function, int to long function, the name implies what it is about. Now, one thing you remember is in a function, the method signal, I will put the method here, it is saying int to long function. So, what is the return type? Primitive long. Name of the method, now look at this method name, apply as long, parameter is int. So, the name of the method is going to be apply all the places, but when there is a primitive return type, it will change to apply as whatever is the primitive type. So, apply as int, apply as long, apply as double, those method name will appear where it says too long, too int, too double. Okay. Fine. So, if I continue with this, int to long, same way, what will it be? What is the next one? Int to double. See all these combinations. Then long to int, long to double, fine. Then double to int, double to long function, when taking care of primitives 1 to 1. Okay. See, this is one input, one output. This line I am writing is one input, one output, all combinations. Now, still there are more combinations pending. Which are those? We had, see, int function. What was int function doing? Taking input as primitive, returning generic value, generic type. Other way around, we have the toInt function, toInt function of t. Same way. So, in toInt function, what's the method name? Apply as int. Okay, method name should become apply as int. There is a toLong function of t. Same way, toDouble function of t. Yeah, how many of these? And there's another line. Okay, so this line is all about 1 to 1, one input, one output. Now there will be 2 input and 1 output. The other combinations are 2 input, 1 output. Okay, so first one, by function of t comma u comma r, right? T and u are inputs, r is the return. Then we have the int by function, comma long by function, comma double by function. Yeah, how many total function we have seen so far? What's the count?
So 17 are
17, right? Okay, so 17 functions you can see, right? Okay. Now special kind of function we'll see. So function, I have put it in function only. So function 17. We have to have total of 43. Okay, and then the next one is, no, these are simple. Unary operator. It's a category, unary operator. It's nothing but a special kind of a function where input type and output type both match. It's the same type. So it basically extends from function only. This is created by extending from function. The name of the method would be apply here, okay, or apply or apply as int, whatever is appropriate here. So we have got unary operator of t. Fine. Unary operator of t, then int unary operator, long unary operator, and a double unary operator. Okay, fine. Same way, the other 4 remaining are binary operator, that category. So 4 plus 4 here. So that should make it okay, it's just the same binary operator of t, comma int binary operator. I had been mentioning about this example. I had given example for int binary operator earlier. Fine. Long binary operator and a double binary operator. Okay, so I think it comes to 43 total. 8 from consumer, 5 from supplier, plus 5 from predicate, so that's 18, plus 17, plus 8, 4 and 4, 8. 18 plus 36, 35, 35 plus 8, 43. Yeah. When you can see, it's just, you have to only remember that these are nothing but some combinations, the various combinations. One input or two input, what is the input type, what is the output type? That's the only thing which is there. So these 43 combinations is what they have given in the java.util.function package. And once they have declared this in java.util.function package, they have used it throughout the API. Okay. Fine, is this okay?
So what is abstract, what are the abstract methods for unary operator and binary operators?
Oh, unary operator, binary operator, it is still the method called apply. It is it extends from function. These extend from function. Okay. Now, what I have shown you here are all the abstract methods from the point of view of abstract methods. But as we had seen when we had written the penalty interface, right? We saw we could add default method, we could add function. We didn't add default, but we added some static methods. Okay. So same way, these interfaces, some of them have, most of them have got default methods which are useful. Okay. I'll just give some examples of default methods here. Okay, what is a consumer? What is a candidate for a consumer? Some processing, right? Take input. I have a collection of account, and then I want to do some processing on the account, right? What kind of processings can be possible? So taking an action was, one I mentioned was, okay, I am updating the interest for all of them. Okay. Or another one could be that, oh, I have to send some, there is some message which is to be sent to all the consumers here, all my account holders. I have to send message to all my account holders. I might have to send SMS, I might have to send email. These are all different types of actions. And I might write a different consumer for each of them. I have one consumer for one kind of action. Fine. I won't write one consumer to do multiple actions. Okay. One consumer, do one action only. Don't think about writing multiple actions in one consumer. Though you may be needing to do at some place, you might need to do more than one action in one consumer. Maybe you want to do more than one actions. Then don't still break it up. It's going to be more helpful. Why? Let me show you why. Okay. What we have is, we got some methods here. We got some default method in consumer, which is going to be helpful here. Okay. So for example, consumer of T has a default method to return a consumer of T. Okay. The name of the method is and then. Takes another consumer as a parameter. Fine. You have another action, right? So one action already defined. So I have got consumer to define different actions, different processings which I might be doing, right? Action on a given type of object T. Okay. So if you have multiple consumers, you will be able to do like this. I want to create a consumer which does 3 actions, right? I have got consumer 1 doing one kind of action is C1, let's say. I have got consumer 2, C2 is another object, C3 is another object, and I might create a consumer C4 equals C1 and then C3, maybe first I do C1, then I do C3 and then C2. You can do something like this. Okay, that's something with consumer. So, consumer has a default method called and then, and the purpose is clear. Okay. Similarly, we will go to the next page. We got predicate. Look in the predicate what happening. For predicate, if I have a predicate of t, okay, if you got a predicate of t, you got methods, the default, we know the abstract methods, I am not talking about abstract method now, okay, but you got default method as well as a few static method as well. Okay, let me put the default method. Default method to create a new predicate by combining with another predicate. But how do we combine them? So, it would return a predicate of t. Okay. Name of the method will be or. Parameter, another predicate. So, you got one test and you want to have another, so you got multiple tests and you can say, oh, this or this or this. That is a test which will be if it's a or, fine, it's the way to combine Boolean values by using or, because they return Boolean values, predicates. Okay, fine. Just like or, what are the other methods? We have got or, we have got and, okay, and yeah, we got XOR, I think, yeah. Lowercase, method names are lowercase. No, we do not have the XOR, sorry, we do not have the XOR, but there is one, there is another default method called negate, but this is without parameter. So, for a given predicate, you can create a negative predicate of that. Okay. Or another one is a static method. Now, here is a static method which would return a predicate of t from another existing predicate by doing a name of the method is okay. Yeah, name of the method is not and parameter is a predicate. So, predicate we call them as tests basically, predicates are tests. Okay. In the collection framework, a place where predicate is used. Okay. Fine. For example, in the collection of t, I will just show quickly, in a collection of t, we have now also got a method to, I think return type is void there, but the name of the method is remove if parameter is a predicate. Okay, this is, yeah. We have collection of E. If there is a collection of E, there is a method called remove if, which will take as parameter a predicate of E, the test. Okay. So, you got a collection of account and you want to remove all those accounts where balance is negative, pass a test, or for any other thing, you want to remove all those accounts where the opening date is less than a particular value, they have become dead accounts maybe. Right. So, predicates are also there in the API, fine, a lot many places. Almost most of the things which we have found, those 43, fine, most of them are being used. Okay, we understand that there is a new API called the Stream API which has come, and that also uses this extensively. They are all dependent on java.util.function now. They are all dependent on these 43 function interfaces. So, to have a hold on that new API, right, the Stream API, you must know about these 43 function interfaces, right? Okay. Fine. See, basically they are all, if I just put it again, they are just based on function. A consumer was only input, a supplier was no input, only output, a predicate input, but output is always Boolean. Okay. And then general thing was a function, input and output. Here is T, here is R. But if it's a unary operator, here is T, here is also T. It's a special case where both the types match. That's a unary operator. Fine. Fine. Input and output. Basically, it's all about input output types. Now, what has not been mentioned here is this: no input, no output, no parameters input, and no return type. Return type is void. Yeah. If that is your requirement, what is the thing which you will use commonly? We don't have anything in the java.util function package, because we already have something which is more standard and is being used very commonly. And what is that one? Runnable. The run method of runnable returns void and no parameters. Clear? Categorization based on the kind of functionality. Oh, this one is purely a processing box. There are no input, it is just a particular processing steps which is to be done, right? Whereas this one, the first one here, oh, it will take input, do some processing on it, but no output. It is not returning. Okay. This can be returning values, doesn't take any inputs, but just emitting out values for you. Fine. And this is for testing purpose. Predicate means testing, to be returning Boolean type. And this is a general one, right? Some input, some output. There is an input type, there is an output type. That is function. Fine. So, that categorization should be very clear. This is how it has been categorized. Okay. Okay. Yeah. So, any questions up till now? Yeah. You have the Java documentation, API documentation. Fine. What you should do is look at the Java API documentation for the package java.util.function. Okay. In this, only thing what you need to look at is the default methods which are available. Some of the default methods, maybe they are going to be useful here. Okay. Another thing which I had been, for which I had given once an example, just to show that what kind of coding may be, how easy it is to write a comparator. So, you may have a look at the interface called comparator, And what has been done in comparator is there are a lot of static and default methods which have been added. All of them meant for creating a comparator object. How do you create a comparator object? Okay. It is mainly meant for that purpose. Fine. See, writing comparator is what? Mainly for the purpose of comparing two objects. Now, given two objects, I should be able to say which is greater, which is less. Okay. And this comparison, it involves comparison. This comparison is based on what? The comparison would be based on some of the fields of the type of element you are comparing. If it is a comparator of t, then it is based on some field of t, whatever t may be. When you are using t, you will be having t as account, you will be having t as a string, you will be having t as something else. Fine. So, some attribute of that type is what will be used here for comparison logic, right. Okay. And therefore, you normally have a getter method, and then you should be able to see in this API how comparators can be created easily, how easy it is to create comparator. Fine. And yeah, that is another place where we might be using method reference. Okay. Yeah, method reference, I think that also needs more understanding, right. So, I will take it in the next session when you are fresh. So, I will take it initially. Okay. Yeah. So, any questions now till this point from today's topic? Initially, we had discussed about the account class and the mainly the account class. Yeah, we had seen the account class, how it has been written. Okay. Yeah, any questions? No? Okay, fine. Then we continue next time on Friday.